problem. The following person.
Yeah, it's fine. You can just
Okay.
rejoin. You can just rejoin.
Oh, someone got knocked
Yeah.
off and then came back on?
I agree.
Yeah.
Oh, okay. All right. So what we're going to do today is we're going to look at the next assignment. Oh, by the way, did you guys watch this on your own yet to take notes on?
Yeah, I watched it already yesterday.
Good. And
Yes.
remember to take notes
Last
on
night.
it. Remember to take notes on it. And then so
Yeah,
you
I
got
submitted that already.
Oh, you submitted it already. Awesome.
Yeah.
So there are two videos, right? So this one and the circle geometry. Those two together, okay, need to go into the 2 of 3. Okay. And what I'm gonna do with you guys today is the next assignment, which is what does it say here? Finding arc measures with equations, I believe. Let me see here. Yeah, arc measure with equations. That's the next one I'm going to do with you guys. Okay, so it's going to be very, very similar to the material from yesterday. I'm going to go into Khan Academy.
Oh, look at that. Kian joined.
Morning, Kian.
Morning.
So we're just going to go into the next assignment. Okay.
Okay.
So remember, we got to click like next like 13 times. So once, twice,
14.
3, yeah, 14, 4,
Thank you.
5, 6, and it does
You
this
can search it
sometime.
up too.
6, 7, 8,
Yeah, wait for me.
9, 10, 11, 12, 13, and 14. We got to click on that 14 times. And oh wait, I'm sorry.
Got it.
You guys got it, but I'm in the wrong class. I'm in my calculus class. So pardon me. I'm gonna go into geometry because that's where we are supposed to be. Okay. So sorry, I want to do that again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. So we are on this guy right here, arc measures with equations. All right. So let's click on this.
Wait, what are we doing? Arc measures with equations?
Yes, arc measures with equations.
Okay, got it.
Okay, so this guy right here. So it's very similar in concept, okay, from the assignment that we had talked about yesterday. If you recall from yesterday, what were some of the vocabulary words that I had shown you guys?
Chord. That's one of them.
Chord, that's right. What's the longest chord in a circle?
The diameter.
The longest chord in a circle is a diameter, okay?
Oh,
The
arc and minor arc.
Say that again, Kira?
Major arc and minor arc?
That's right, major arc and minor arc. Okay, so I have right here, we have a minor arc, right? So AB over here, okay, is a minor arc, whereas ABCB, okay, going all the way around, that would be the major, okay? All the concepts, okay, that we had talked about from earlier in the year, okay, they all still apply, okay? So concepts of vertical angles, parallel lines, similarity, they all still apply. So looking at this right now, okay, the question here is asking for us to find out what is the arc measure of BC in degrees, okay? So you're told that this angle over here, okay, the central angle, BPC, okay, is given by 4k plus 159, and angle APD is given is described as 2k plus 143. What do we do with this situation here? Anybody know?
Oh,
Yeah, Kira.
well, angles BPC and angles APD are vertical angles, and as I say, vertical angles are congruent, so we just set them equal to each other and then find out what K equals to, and then we plug what K equals to into the equation, and then we get our answer.
Excellent. So we apply concepts of vertical angles in there, okay? So I'm going to give you guys maybe 30 seconds to go about doing that, okay? Because I think
Okay.
everyone here is capable of doing that. Go ahead.
Wait, never mind.
Wait, what's the exercise called again? I can't find it. It's called
What is this exercise called?
Hi.
Arc
Yeah.
measures
Arc
with
measure
equations.
with equations.
arc measure with equations. Okay, let me try to find that. Oh god, this is getting hard. Got it. Arc
So,
measure with equations.
right. So what you're supposed to do here, just like Kira said, we're supposed to equate these two, right? So if you were to equate these two, I'm just going to do a present screen
Aren't you doing it right now?
with my tablet.
Oh, okay. Right.
Can everyone see my tablet? Let me see if it's working.
Yeah, I can see it.
You can see it?
Yeah, just the presentation screen. You haven't changed it yet.
I haven't changed it yet.
Nope.
Let me see here. As I'm using an iPad today.
Okay,
is-
it's okay.
Let me see here. Okay. It's not doing it. So I'm gonna switch out of this. This is not good. Okay.
So K would equal 3 in this case, right?
K would actually equal to, say that again.
K would equal to 3.
I think -3 if I'm not mistaken.
Yes.
Right. So I want to just really quickly. Sorry for the delay here. My iPad is not. I mean, I don't know the interface of the iPad as well as I do with the my Android tablet. Just give me a second.
Okay, it's okay. They're both different things anyway. One is Apple, one is Android. Had that before.
Okay, so I want to present screen on this one. Okay, there we go. So the this is not you guys, this is calculus. Let me erase that. Okay, so the situation that we had before, I'm just going to quickly redraw that. It looks something like this. And you were given something like this. And the angle above was 4K plus 159 and 2K plus 153, right?
Oh, that makes me
So remember, these are vertical angles here. So therefore, we have 4K plus 159. Kian, do we equate them or do we add them?
Sorry, what?
Do we equate 4K plus 159 or do we add them?
We equate them.
You equate them. 4K plus 159 will equal to 2K plus 153. If I subtract both sides by 2K, I'll end up with 2K plus 159 is equal to 153. Subtract both sides by 159. I'll end up with 2k is equal to
You'll get
negative 6. Finally,
-6.
k is equal to negative 3. Hey, Ricardo, what do I do after this? Ricardo, are you there?
He is here, but his microphone's off.
He's muted.
Muted. Okay.
Yeah, I know. So his camera's turned off.
Michael, what do we do in this case? Well, after we found out what k is, plug it in. Okay, and it doesn't matter which one.
Plug it in.
It doesn't matter. Remember, we're looking for arc
No, you
BC,
can
right?
do both.
We're looking for arc BC. So it really doesn't matter which one because
Oh,
they're
okay.
vertical angles anyway. So 4 times negative 3 plus 159. We end up with negative 12 plus 159. Or really, this comes out to be
I'm sorry,
137.
7.
Okay?
Mm-hmm.
And if I pop that in, we should get that nice sounding bell. Oops. Okay. And we're going to move on to the next one.
It's the same
Got it.
numbers we just got.
Same
So
concept?
we already know what K is in this case. So all we have to do is just figure out what BDC is.
Okay. Suggestions on what to do, though, in this case.
Uh,
So the
we could
next
do
part
it
here
out
is
of
asking for us to find out what
360 this
BDC is. So BDC is going all the way around, right?
Right.
How
I
do we
know
do
what
that?
both those numbers are, so maybe we could do what
Oh, I drew it
147
wrong.
plus
BDC
147
goes like
plus
this.
2p equals 360, and then we
Sorry,
just
I drew
know
it
what
wrong.
we'll find. What p is.
Say that again, Emmett.
We can do 147 plus 147 plus 2p equals 360, so we'll know what p is. Or we don't need to do that. That's
I mean, if we combine P with 2K plus 153, that already equals 180. It's the diameter. So
Right.
all we have to figure out is what CD is, which isn't a problem because we already found out what 4K plus 159 is, and that's 147. If we subtract 180 by 147, then we're going to get what CD is.
I totally agree with that. Okay, we can find out what arc CD is by subtracting 147 from 180.
Right.
That is absolutely true. We can find out what that is, and if we do that, we'll end up with this angle that I'm highlighting in blue, right? And once we have that, you know, we have the same thing on the other side, right? So those two things plus 147 will give us the arc that's highlighted in pink. But there's something even simpler that we can do. I don't know if you guys notice something else here in this diagram. We can do this in like one step.
Really? How?
Yeah,
you just add p to 180.
not even. Look, you see what is the arc that's highlighted in green right now?
47 by 360, and then we get our answer.
Kira, you are the voice of wisdom here, right? So we have BC here. BC is that arc measures 147. And Kira, say that one more time. BC,
Oh.
and then all that stuff that's highlighted in pink. What should they add up to?
100 BC will add up to 137.
Right, BC is 147. So all the stuff that's highlighted in green and the stuff that's highlighted in
213.
pink should add to 360, right?
Well,
That's all it is. Okay. So arc
213.
BDC is simply 360
213.
minus 147.
It's
Which
213.
is 213.
213. Awesome. So I want to put that in and we
I
should
say
hear that
first.
magic bell. Awesome.
Got it.
All right, the next one here. This one's a little different. Okay, I'm just going to quickly draw this out. So we have something like this. The circle, and then we have 3 radiuses drawn. Something like this. 1, 2, and 3. Something like that. 13n minus 16. Uh, 6n and 7n plus 12. And the task is to find out what arc BC is.
So 26n minus 4 equals 360.
And how did you? What did you do exactly again?
I added up all the angles and added the variables, and I knew that all of the angles added together would equal to 360. That's what a circle would equal. So I just did that.
Awesome. So 13, 6, and 7 add up
Michael,
to
mute yourself.
what is
What
that?
you're gonna say?
Say that again, Kian.
Nothing. It's just I was telling Michael to mute himself because he was singing.
Oh. So we add them all up together. We got 26n plus 12 is equal to 360. Subtract both sides by 12. We get 26n is equal to 348. And if we divide both sides by 26, Keen, do you know what that is? What is 348 divided by 26?
48 divided by 26 is mine is a fraction, but it's like 174 over 13. So if I hang on, let me. You said 348.
Yeah, divide by 26.
Yeah, that's 13.3846153.846. But if we're gonna round it to the nearest hundred, then it's gonna be 13.38.
Okay. The question is not to find out what n is, but to find out what arc BC is, right? So once we have this, okay, we got to go back and we got to substitute substitute n is into this guy right here. So if we multiply n by 6, what are we getting up with then?
36n?
Say that again.
Wait.
We had to find out what n was, right?
Right.
And then
So
after we
just
find out what
add
n
up all
is,
of those things and make it out of 360.
or just figure out what 6n is, because we needed to find out what arc BC is, right? Wasn't that the
Wait.
question?
Wait, hang on. I
You
think there's a
forgot
small error there because you just
You forgot
You-
the minus.
Right.
forgot
No, I got a
16.
whole number when I did that.
or negative 16.
No,
Yeah.
it's I
forgot
got a
negative
whole number
16.
when I
That's
did
why
that.
we got
It's
negative
negative
16.
4, and then it's 384
No,
divided by
'cause-
26.
Yeah, I forgot minus 16. Sorry about that, guys. It's 13n. Yeah. It's like this.
So it's
13n minus 16
364.
plus 6n plus 7n minus plus 12 is equal to 360. And we do that. My bad, guys. So we end up with 26n minus 4 is equal to 360. 26n is equal to 364. And what will n turn out to be as a result?
It'll be 14.
14.
And then
So then if we're looking for 6n, right, arc BC is just 6 times 14, or that's simply 84. Okay. And this is our third question. No, this is our fourth question. Okay, so we got to figure out what YWZ is. YWZ. Okay. Very, very, very similar to the first question here. So I'm going to draw it out. So it looks something like this. And we have two diameters. And this is 5W plus 4. And then the other one is 11W. And we got to figure out what W, X, Y, Z. And we're looking for W, Y, Z, the arc. Okay, so what's the strategy here?
Equate 11W and 5W plus 4.
We actually don't.
We
And I'll tell you
equate
why,
both of them to
right?
180.
Why would we want to add those two things and equate it to 180 though? Emmett is right, but why would we want to add these two?
Because they're not equal.
To each other.
Why are they not equal?
Because they're not vertical angles.
They're not vertical angles. They're also otherwise known as, this is from earlier in the year, this is known as what kind of a pair?
Supplementary. Complementary.
Yeah.
You're right first time. It's supplementary. These two angles are
sorry.
supplementary. They are linear pairs. Okay.
Wait, but technically we don't know that they're not. I mean, we don't know they're not.
It was said in the problem here. Let me see. In the figure below, YW and XZ are diameters. So it says that they are diameters. Like these two lines are straight lines. Okay, they're diameters. So any two adjacent angles would form a linear pair. Any two adjacent angles would have to be supplementary as a result.
Right. No, I'm saying that we know that's supplementary, but we don't know that those angles aren't congruent.
Right. We don't know whether or not they're congruent. That is true. I do agree with you on that. However, we do need to say that these two are supplementary. Okay. So because they are linear pairs. So 11W plus 5W plus 14 will equal to 180. And then here we have 16W plus 14 is equal to 180. Subtract both sides by 14. We end up with 166.
76. It was. Wait,
You're right.
it's just 4.
Say that again.
It's just 4, not 6. 14. You wrote 14 down.
I have 14.
No, it's just 4.
It's just 4. It's not 14.
Yeah.
Oh, you're right. Oh, okay.
And that's 176.
Okay. So I mislabeled here. Okay. So it's going to be 176.
Which gives us 11.
So W is equal to 11. But then to answer the question, Michael, how do we do that?
Since it's YWZ, maybe we could do 11 times W times this times 11 times W, since they're vertical angles.
We could do that method that Kira employed last time, where you just subtract one of the slices of it.
So you
So
see
we could
this
just
right here that's in green?
Oh yeah. So 360 minus 5 times 11 plus 4. So
That's it. So it's going to be 360.
360 minus 59. That is 301.
So it becomes
301.
301.
Got it.
Okay.
Got it, Mr. Chan.
So if I punch that in,
301.
And that's pretty much it. Okay. So this assignment, pretty easy as an introduction
301,
to
you said?
301, yes. Pretty basic as an introductory
The answer was
to
301.
as an introduction to circle geometry. Okay, that's pretty much it for this week's assignment. Other than those two other occasions where I want you to take notes from the videos. Okay, have you guys started on like the 2 of 3 and the 3 of 3 yet? Okay.
No,
Yep, I
not
just-
yet. I'll do it later today.
So other than that, if you guys can get through, if you guys get through those two note-taking assignments, you're pretty much done for the
Well,
week. What I'm going to do later on today, I'm going to post on post in Google Classroom other enrichment assignments for you guys to work on. Okay, and you are welcome to work on those if you like. You know, if you guys want to take on other challenges, but you know, aside from this, you guys will be done for the week. Okay.
Okay, that's nice.
Do you guys have any questions for me?
What's next after this one?
After this, okay, what we're going to do is we're going to look at, we're going to continue in the circle geometry here. So if you want to go even further on your own, okay, I would encourage you to continue, you know, moving on in Khan Academy in the circles portion right here. Let me show you what I mean. Let me see here. Resume presenting. Okay, so this is what I mean. If you go back, like we just finished this guy right here right now, yeah? So if you want to continue moving on in the Khan Academy assignments just because you want to move ahead, you know, of everyone else, okay, because you feel like you have the agency to do that, okay, continue doing that. You can move on, watch the other videos, and then do the other assignments in here, okay? We are going to be on circles at least for another week to 2 weeks. Cool?
Okay. Yeah.
Okay. All right. Are there any other questions before we sign off?
What is a chord again?
Sure. A chord. Let me see if I have a diagram here. Okay.
What's the difference between a
need to
chord
go
and a
back
line?
into
That's the part that confuses me.
So a chord actually is a line. Let me go
Oh,
back.
really?
Yeah, a chord is a line. Does anyone know how to answer that question, guys?
A chord. Let me check my notes. A chord is something that passes through the circle. Is a line that passes through the circle but does not intercept at the midpoint, I think.
Oh,
It actually can intersect the center. A chord, very, very simply, Michael and
Okay.
others, right? A chord is this. So you have a circle, right? So a chord is just a line drawn from one point on the circle to the other.
it has to pass through like 2 points on the circle, right?
So it's simply a line drawn from one point of the circle to the other. That's all it is.
Oh, can it also like represent a diameter if it's drawn from the like very center?
So you know what? This was the question I posed in the very beginning, right? Michael, what is the longest chord in a circle?
The diameter, the center.
That's it. The diameter is the longest chord in the circle. Okay. There are other things that we can. There are other things that we can do to talk about, like, you know, different things that we can draw in a circle. And I think in that video that Sal Khan had talked about, right, there were other things in there that he had talked about. Other things that you can draw inside of a circle. Let me just quickly recap what those are, just because maybe it'll ring a little more meaning coming from me, maybe, possibly, I don't know. So you can draw a line, not just from one end, not just from one point of a circle to the other, but you can draw a line passing through a circle, right?
Oh, okay, got it.
So there's a name for this though. This is not a chord. What is this called? Starts with
was
letter
it a
S.
segment?
No. Does anyone recall from watching that video? No one here recalls?
What's the next letter? If it's
So it's actually it's the next letter is E actually, and then the third letter is C. This is referred to as a secant.
secant, right? What's that?
So it's a line drawn through the circle. Okay, so this is a secant. Okay,
It's not the same as a chord.
it's not the
right?
same as a chord, no. And then a chord, it's very similar to a chord though. A chord is this. A chord is a line drawn from one point to the other. Okay, on a circle. This guy here is a chord. And then there's another thing that we can draw to a circle, right? So I have a line passing through 2 points on a circle. That's called a secant. Can I have a line drawn touching the circle at one point only? Is that possible to draw? It
Yes.
is.
Yeah.
What is that
That's
referred
called
to as?
That's just called a line or
No,
tangent.
starts with the letter T. I think that was in the circle glossary video.
A
Tangent.
A
There you
tangent.
go. This is a tangent.
That was what I said.
So this is a tangent. This guy right here is a tangent. Okay, again, just going through some of the nomenclature, okay, for things to so that we can communicate in the same way. And then this guy right here that I'm going to call theta, what is that referred to as? Starts with the letter C. It's actually 2 words.
Theta is equal to
C. The first word is C, and then the second word begins with the letter A. This is the central.
central angle.
Yeah, it's a central angle. This is the central angle.
Got it.
Okay. This is a central angle. It is also possible, and I think in the circle glossary video that you guys had seen, there was also another thing that we can do. Yes, that is the central angle. There's something called an inscribed angle. Was that brought up? I think that was brought up in the video that Salkan had talked about. So, so right now, okay, this angle that I'm highlighting right here, right? This is the central angle because it's the angle formed by 2 radius. In this case right here, this angle over here that I'm highlighting up top here, okay, that angle is formed by what? 2 what?
2 chords.
2 chords. That's right. Okay, so in this case, okay, we refer to this guy. I'm going to call it beta here. This is called an inscribed angle.
So a central angle is formed by 2 lines, while a inscribed angle is formed by 2 chords, right?
2 chords, and actually, it's not simply just 2 chords. It could also be formed by. By a chord and a tangent. Okay, this is
Really?
another.
Wow,
This is
that's
another.
incredible. I never even knew that.
Okay, so this is another thing that it can do. So this guy right here, okay, that is what we call an inscribed angle as well. So this guy, which I'm also going to call angle beta, right? Those are inscribed angles. So the inscribed angles, okay, it's on the circle. So think about it like that. An inscribed angle is on a circle. A central angle is inside of the circle. Okay. So these are all the terminologies, and again reiterated. That was from the that circle glossary video in Khan Academy. Okay. All right. So if you don't remember this, take a screenshot of that so that you'll have this information again. Okay. And I'm gonna stop the recording here.
Thank you.